Welcome back to Mr. Psycho. Today, we're going to dive into one of the most mind-bending and exciting concepts in modern science, quantum teleportation. Now, I know what you might be thinking. Teleportation sounds like something straight out of a sci-fi movie. You've seen it in shows like Star Trek or The Fly, where people and objects are teleported instantly from one place to another. But what if I told you that scientists are making real progress in something eerily similar? This isn't about teleporting people across the galaxy, not yet at least, but we are talking about transferring quantum states of matter across vast distances without actually moving the matter itself. It's real, it's happening, and it's probably one of the most mind-blowing breakthroughs in physics today. To understand how quantum teleportation works, we need to take a quick dive into the basics of quantum mechanics. At the microscopic level, the level of atoms and subatomic particles, the universe doesn't work the way we expect. For example, particles like electrons and photons can exist in multiple states at once, a phenomenon known as superposition. But it gets even stranger. When two particles become entangled, they essentially share a connection that allows them to affect each other instantaneously, no matter how far apart they are. This connection is what Einstein famously called spooky action at a distance, and it's the foundation of quantum teleportation. Here's the mind-blowing part. If you have two entangled particles and you do something to one, say you measure its properties or change its state, the other particle will immediately adjust to match, no matter how far away it is. It's as if these particles are linked by an invisible force, instantly sharing information. It's one of the most puzzling aspects of quantum mechanics, and it's what makes quantum teleportation possible. But let's back up a bit. What is quantum teleportation exactly? In the simplest terms, it's the process of transferring the quantum state of one particle to another without moving the physical particle itself. To visualize it, imagine you have two entangled particles, A and B. Particle A is in one location, let's say in your lab. Particle B is far away, maybe even miles or kilometers away, yet they share this unbreakable connection. Now you introduce a third particle, particle C, that you want to teleport. This particle has a specific quantum state. Maybe it has a particular spin, or its energy level is unique. Your goal is to take the state of particle C and transfer it onto particle B without moving C physically. So, how do you do this? First, you perform a special kind of measurement on particle A and particle C. This measurement doesn't just observe the particles, but essentially merges their quantum states in a very specific way. Once you've made the measurement, you then send a classical signal, just a regular everyday communication, to the location of particle B. This classical message tells particle B how to adjust itself so that it ends up in the exact same state as particle C. In essence, you've transferred the quantum state of particle C to particle B across a distance, in a process that scientists call quantum teleportation. Now, before you get too excited, let me clarify one important thing. Quantum teleportation doesn't involve transferring matter in the traditional sense. We're not teleporting physical objects or people, at least not yet. What we're teleporting is the information that defines the quantum state of a particle. Think of it like transferring a piece of data, not a physical object. So we're not sending particles instantly across the universe, but we're transmitting the essential information that makes up the particle's quantum state, and it happens incredibly fast. So why does this matter? Well, for one, quantum teleportation could revolutionize the way we think about security and communication. If we can teleport quantum states, we can create unhackable systems. Here's why. Any attempt to intercept or measure a quantum state would change it, alerting the sender and receiver that someone is trying to interfere. So you can imagine a quantum internet, where messages are sent through entangled particles and are completely immune to eavesdropping. This would be a game changer for things like secure communications, banking systems, and government operations. But there's more. Quantum teleportation also opens the door to quantum computing. Quantum computers are already showing us that they can perform certain calculations far faster than classical computers. But to fully harness the power of quantum computing, we need to connect quantum computers to each other over long distances. Quantum teleportation could make this possible by enabling quantum states to be transferred between quantum processors, creating a network of quantum computers that work together as a super powerful system. This could lead to breakthroughs in fields like artificial intelligence, drug discovery, and climate modeling. Now, while all of this sounds amazing, it's important to remember that we're still in the early stages of quantum teleportation. Right now, scientists have been able to teleport quantum states of individual particles and even atoms across small distances. But humans? Well, we're a long way from teleporting ourselves. In fact, teleporting a human would be an impossible task with current technology, since humans are made up of an unfathomable number of particles. To teleport a human, we'd need to record the quantum state of every single atom in the body, something like 10 to the power of 28 atoms for just one person. That's a lot of data, and right now, it's way beyond our capabilities to even begin to think about how we would make that work. Still, just because we can't teleport people today, doesn't mean that quantum teleportation doesn't have profound implications for the future. It's opening up new possibilities in quantum communication and quantum computing that could change the way we interact with technology, and even how we understand the very nature of reality itself. So, why should you care about all of this? Well, quantum teleportation is a glimpse into the future of technology. It's a hint of what could be possible when we start to fully unlock the mysteries of the quantum world. Imagine a future where all of our communication is instant and unbreakable. Imagine quantum computers working together in real time, solving problems we can't even comprehend today. It's not just about teleporting particles. It's about creating a whole new way of interacting with information technology and the universe itself. As we continue to explore these strange and wonderful realms of physics, the line between science fiction and reality gets blurrier every day. And who knows, maybe one day we'll be telling stories about the first successful teleportation of a human, just like we now tell stories about the first flight to the moon. But for now, we're just beginning to scratch the surface of what quantum teleportation can do. If you found this topic as mind-blowing as I did, don't forget to hit that like button and subscribe to Mr. Psycho for more deep dives into the weird and fascinating world of science. Thanks for watching, and remember, in the universe of quantum mechanics, the truth is stranger than fiction. Keep exploring, stay curious, and I'll see you in the next video.